Hey everyone, Mr. Fritz here. In this video, we are going to talk about vector subtraction. But before we do, let's recall what negative vectors and the zero vector looks like. Remember that negative vectors are basically the same size vector. They are just in opposite directions. So they are parallel because they are kind of like the anti-vector of the other. So if this A is a vector, then negative A would be the same distance or same size, same magnitude, but just in the completely opposite direction. So keep that in mind, and let's think about too what the zero vector is. If we have negative vectors up here, zero vector would be what you get when you would add a vector plus its negative. And that should really make sense. Like if I start at one location and I go to another, and then I go straight back, that really is the same thing as if I never moved in the first place. So a zero vector is just what you get when you do a whole bunch of addition of vectors, and it all comes out to be netting zero displacement. So if we put those two concepts together, we can subtract vectors by doing the following. All that we need to do to subtract is to add the negative, add the negative vector, and that's the same thing as subtracting. So if I wanted to subtract, for an example, in this example, I want to subtract vector A minus vector B. Really, we can think of that's the same thing as taking vector A and subtracting, or rather adding, whatever the negative of vector B is. So, I mean, we all know this is the same thing arithmetically. To add a negative is the same thing as subtract. But when we think about this as vectors, we know what a negative vector looks like, and we're going to add them together using the same adding skills we learned in the last video. So what kind of helps me when I'm adding these together is I'm going to take vector A and I'm going to plot it like this. So vector A goes up 1, 2, 3, 4 and over 1, 2, 3, 4, 5. So let's start over here and go up 1, 2, 3, 4 and over 1, 2, 3, 4, 5. Here's my vector A, and let's label that vector A. And what I like to do in this little box is let's just kind of visualize what vector B looks like, or rather what negative B looks like. So what I'm going to do is I'm just going to drop my end point down, my beginning point down, and just kind of go in the opposite direction. This is the same size vector, but it's in the opposite direction. So this vector that I just drew is negative B, negative vector B. So right now, if I were to add regular old vector B, it would look something like this. And you know what I'm going to do? I'm going to make this a dotted line, just to kind of visualize. If I were to add B, I would go up 2 and to the left 3. I would go up 2, to the left 1, 2, 3. This is kind of what adding vector B would look like. But instead of adding vector B, I'm going to subtract vector B. Or you can think of it as adding the negative of vector B. So what I'll do instead, if I go back to my normal color scheme here, instead of going up and to the left, I'm going to go down 2 and to the right 3. And that, in essence, is going to be like adding negative vector B. The resultant between these two is going to be from the beginning of A to the end of B, just like before. But now what I've done is I've essentially subtracted these two vectors by adding the negative. So this is vector A minus vector B. So that's all you need to do in order to subtract a couple of vectors. Let's see another example of what this looks like. So here are 3 vectors, and I want to find what vector r minus s is. I want to find what vector s minus minus t minus r is. So let's start off with r minus s. I'm going to grab my arrow tool here, and let's see, I'm going to, in blue, graph vector r. And that's over 1, 2, 3, 4. 1, 2, 3, 4. That's vector r. And I'm going to subtract s. And just like before, what I'm going to do to help kind of visualize is I'm going to draw a picture of what negative s looks like over here. So this would be down 3 into the left 1. So I'm going to go from the end of this vector, I'm going to go down 1, 2, 3 into the left 1. So that is vector negative s. And now if we add these two vectors together, we get the resultant of r minus s. And that is this vector right here. So that vector that I just drew is r minus s. All right, so that one's done. Let's see what this looks like. Now remember, I can add any number or subtract any number of vectors together, and that's what I'm going to do here. I'm going to start with vector s, and then I'm going to subtract t, and I'm going to subtract r. So why don't I do what I did before, and let's actually kind of visualize what these negative vectors look like. Negative r is going to look like this, and negative t is going to look like this. Wrong way. Negative t will look like this. And really what I'm doing is I'm just kind of shifting my starting or ending point over one to kind of visualize that, but I'm just counting opposite in both my x and y direction. So let's see, I want to start with vector s over, where do I want to start it? Right over here. And vector s is going to be up 3, 1, 2, 3, and over 1. There's my vector s. Let's write that in. I want to add to vector s negative t. So that vector is going to be this one here. I'm going to go up 2 and to the right 2. Up 2 and to the right 2. That is vector negative t. And then I want to add the vector negative r to that. And that's going to be to the left 1, 2, 3, 4. 1, 2, 3, 4. So that is vector negative r. Once I add all three of these vectors together, I'm going to get the resultant vector s minus t minus r, and that is this vector right here. So let's label that vector s minus t minus r. These are all vectors, so I'm just going to throw little arrows on top of all of them. So there you go. Adding is the same thing, or rather subtracting is the same thing as adding the negative. So we've got a you-try example here. This one's a little bit tricky. It's going to take a little bit of problem solving this, but let me kind of demo how this looks. We want to use these vectors r, s, and t to come up with some way to diagram what vector rs would look like. So if I wanted to get from here, if I want to start at r and end at s, how can I use these vectors to get there? So think about, I'm going to definitely have to use r and s, but maybe the direction in which I'm traveling will be helpful to think about how I can use r's, s's, and t's to describe that vector. So pause this video, see if you can't figure out how to use, you're going to have to use some negative vectors in here, but how to create a new vector for rs, for sr, and st using just r, s, and t vectors. So give this problem a shot. All right, so the solutions look like this for rs. I'm going to take the negative vector r and the positive vector s, and that's going to give me a resultant of rs. And the same process is going to follow for these other two vectors. So that is vector subtraction. We've got one more type of vector operation, and that would be scalar multiplication. We'll check that out in the next video.